almost every drug of addiction, whether we go from nicotine to alcohol to heroin to cocaine to amphetamine, almost every drug of addiction hijacks that dopamine system we were talking about. We find when that circuitry is not working that you can get profound loss of motivation, apathy. When that circuitry is on overdrive, because it's been hijacked by these drugs, you get states of hypermotivation. So, of course, this is going to be overly simplistic to think dopamine levels are the only factor that affect our motivation. But it certainly turns out to be a very important factor in graduating the level of motivation we have to seek particular outcomes.
Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. My guest today is Dr. Masud Husain, who is a neurologist and neuroscientist at Oxford, making key discoveries about the relationship between motivation and pleasure. Today, we discuss what really determines our level of drive and determination to do everything from getting up to go to school or work to pursuing long, hard challenges that last many years. We start off by talking about the opposite of motivation, which of course is apathy. And as you'll learn, perhaps surprisingly, apathy is separate from one's desire for something. We also discuss something very useful, which is how you can change your own perception of your own effort level. Today's discussion really gets to the heart of motivation and procrastination and how anyone, healthy or otherwise, can leverage that understanding to their benefit. As you'll soon hear, Dr. Masud Husain is a remarkable scientist, neurologist, and communicator. Indeed, he's the author of a spectacular book. I've read it. It's entitled Our Brain, Ourselves, and it's a terrific read if you want to learn more about how your brain works, how it can change over time, and how it makes you who you are. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero cost to consumer information about science and science-related tools to the general public. In keeping with that theme, today's episode does include sponsors. And now for my discussion with Dr. Masud Husain. Dr. Masud Husain, welcome.
Thank you for having me.
You've worked on a huge variety of topics. Alzheimer's, attention, apathy. We're definitely going to talk about apathy. Spatial neglect, which I'm guessing most of our audience probably doesn't know exactly what that is. I'd like to start with the one that sounds like a bit of a downer, but as a window into understanding motivation and these states of excitement that most of us would like to be in. But let's talk about and really define through your lens, what is apathy? How does the brain bring about this thing that we call apathy? And is apathy just a lack of motivation?
Yeah, I mean, these are big questions. And I think the way we've approached them is somewhat serendipitous in the sense that, 15 years ago, I wasn't studying apathy or motivation. Like many people, I might think someone's lazy or they're highly motivated, but that's a sort of psychological state. It's a personality. And it was only about 15 years ago I started beginning to be aware that there may be an important biology underlying motivation. And when that biology goes wrong, it can lead to loss of motivation and even pathological apathy. And the way this happened was completely out of the blue. I was then working in London at the National Hospital for Neurology in Queen's Square at UCL. And we received a letter from a doctor describing a guy in his 30s. And this guy had been a highly productive person. He was in finance. He was also really liked socially, had a wide network of friends. But suddenly, he had become completely different. From being highly motivated, he went to, I'm not interested. I can't be bothered. And that was both at work as well as with his friends. So people began to think, this is something really different in this guy, David. What's happening? They wondered if he had become depressed. That's why he wasn't really functioning. And he went to see his doctor, who started him on an antidepressant, but it made no difference. He was still the same. So he lost his job. He got fired because he had lost motivation. And he was so apathetic that he couldn't be bothered to get social security benefit. So his friend said, okay, come and stay with us. And they regretted it almost immediately because David did nothing. He just sat there in a chair all day long, waiting for his friends to come back, do the cooking, clean. They needed to prompt him to have a shower because he literally just sat there. His level of motivation was almost zero. When we got to see him, and it was difficult because he'd never come to his appointments, I had to phone him up to say, look, I am going to be here tomorrow. Please come. And he grudgingly said, okay, I'll try and make it. And he was, of course, late. He came, and there was this very sad guy. He was disheveled, really not looking after himself, stains on his shirt. But the one thing he wasn't was unhappy. He was absolutely happy about life, right? Which was the perplexing thing. He'd lost his job. He'd lost his apartment because he wasn't paying the rent, couldn't be bothered to get Social Security. But there he was, really happy about what was happening in life, looking forward to something that he didn't know what, but he was still looking forward to good things in life. So when I asked him, why aren't you doing anything when you're at home? What would you normally do? I would listen to some music. So why aren't you listening to music? Because it would take me some time to put my music system together. How long would it take? 5 minutes. So this was really sort of revelatory for me. The effort of putting the cables together for his music system, taking out the loudspeakers, was too much in terms of the pleasure he could obtain from listening to music. It turned out that David had a very unusual neurological problem. His MRI brain scans revealed that he had 2 tiny little strokes in the basal ganglia. These are deep nuclei in the brain, which are evolutionarily well conserved. They go back to the earliest vertebrate that we still have, the lamprey, 360 million years old. And the key thing that we've discovered from the neurophysiology of the lamprey is the basal ganglia are important in linking motivation signals to action. Some people call it motivation to act. So in an organism like the lamprey, motivation signals might be hunger or sex that lead to action to fulfill those goals. In David, these strokes in the ventral striatum, what's called the nucleus accumbens in animals, led to no motivation signals leading to action. Nothing happened. But if you prompted him, go take a shower, come on, he would do it. But of his own volition, he wasn't motivated to act. And that was really something that was extraordinary for us, because here was a man who'd been highly motivated, and that motivation had been extinguished by these 2 tiny little strokes, which didn't affect him physically, but affected his behavior. And the studies that we performed with David to try and understand this led us to the concept that we might be able to deconstruct this nebulous thing called motivation.
May I ask a question? It's fascinating, and I'm sure everyone, including myself, is also wondering what became of David. But before you tell us, was it the case that he would feel overwhelmed? Like, I want to listen to music, but that 5 minutes feels like a huge effort. That's a long effort. Or was it the case that he didn't really want it either? Because the way you've described these lesions is a severing of the wanting from the engagement in the process to have.
Yeah.
But of course, as you and I know, neural circuits are never that simple.
No, of course not. Yeah. And he never expressed it unless we asked him. But he would say that it's too much effort to put this system together. So even if he was asked, what would you like to do? He might say, I'd like to listen to music. Why aren't you doing it? Because it's too much effort to do it. Right. And that became a real insight into how our brains work when we make decisions about, is this potential action worth the effort in terms of the reward that will arise from it? Because it turns out that if we look at apathy across many different neurological disorders, one common trait that we found when we asked people, is this particular option worth the reward if it was requiring this much physical effort, we find that everyone is willing to work for high rewards. But the difference between motivated people and apathetic people is at the level of the low rewards. Apathetic people are more inclined to say, nah, I don't think this is worth the effort, so I won't do that option. That's a really interesting signature that we found when people make that decisions. But in someone extreme like David, almost nothing incentivized him to put in effort to act unless he was prompted to do so. But going back to what happened to him, one of the things we've learned from the neuroscience of the basal ganglia and motivation to act is that dopamine is a key neurotransmitter, a key chemical in the brain, which is important in the neural circuitry. And that's when we thought, okay, is there anything we can do for this guy to improve his motivation? So initially we tried levodopa, L-dopa, which is the drug that Oliver Sacks describes in Awakenings, and many people have seen the film, and it's used a lot in Parkinson's disease for treatment. We slowly ramped up that drug, but seemed to make absolutely no difference behaviorally to David or on our tests of reward sensitivity. We developed some ways of measuring that. So we were about to give up, and then I suddenly thought, look, let's use the other drug that we use for the dopamine system, and that class of drugs acts directly on dopamine D2 and D3 receptors rather than being a precursor to making dopamine in the brain like levodopa. And this drug, ropinirole, latches onto dopamine receptors directly and stimulates the dopamine circuitry. So we slowly ramped up this drug, thinking, is it going to be any different or not? But 3 months after we started this medication, David came back to see us, and I did not recognize this guy in the waiting room because, first of all, he'd had a shower, he'd had a haircut, he was wearing a suit, he had a new job, and most impressively, he had a new girlfriend. Because in the state he'd been in, he was seeing nobody. But he'd obviously been motivated to get out there and, see if he could find a new partner. I was absolutely delighted for him, but so astonished that we could go in a human biological system where someone has tiny lesions in the basal ganglia and has their motivation extinguished. We could go from that to recovering motivation by using a drug that we already have that affects the dopamine circuitry. And of course, David is really rare, this kind of bilateral, and both sides of the basal ganglia being affected, tiny little strokes. This is extremely rare. It's reported, and it leads to pathological apathy. But it turns out that apathy is really common across neurological disorders. And the way we've thought about it is if a pathological process, whether it's a stroke or whether it's Alzheimer's disease or whether it's Parkinson's disease or even some inflammatory disorder affecting the nervous system like multiple sclerosis, if that pathological process is affecting this circuitry, it can lead to loss of motivation. And that's what we're really interested in, is to think about the circuits that are affected and also trying to deconstruct motivation in terms of what's actually going on in the brain. What is this circuit really doing for us that leads to this behavior we call motivated behavior?
I'd like to take a quick break to acknowledge one of our sponsors, David. David makes protein bars unlike any other. Their newest bar, the Bronze Bar, has 20 grams of protein, only 150 calories, and 0 grams of sugar. I have to say, these are the best tasting protein bars I've ever had, and I've tried a lot of protein bars over the years. These new David bars have a marshmallow base, and they're covered in chocolate coating, and they're absolutely incredible. I, of course, eat regular whole foods. I eat meat, chicken, fish, eggs, fruits, vegetables, etc. But I also make it a point to eat 1 or 2 David bars per day as a snack, which makes it easy to hit my protein goal of 1 gram of protein per pound of body weight. And that allows me to take in the protein I need without consuming excess calories. I love all the David Bronze Bar flavors, including cookie dough, caramel chocolate, double chocolate, peanut butter chocolate. They all actually taste like candy bars. Again, they're amazing. But again, they have no sugar and they have 20 grams of protein with just 150 calories. If you'd like to try David, you can go to davidprotein.com/Huberman. Right now, David is offering a deal where if you buy 4 cartons, you get the 5th carton for free. You can also find David on Amazon or in stores such as Target, Walmart, and Kroger. Again, to get the 5th carton for free, go to davidprotein.com/Huberman. Today's episode is also brought to us by BetterHelp. BetterHelp offers professional therapy with a licensed therapist carried out entirely online. I've been doing therapy for a long time, and while it's not always easy, every time I do a therapy session, I come away feeling better and knowing that the time was well spent. And that's because whenever I finish a therapy session, I come away with a valuable insight or new perspective on something I'm working through, whether that's with work, with relationships in my personal life, or with my relationship to myself. With BetterHelp, they make it extremely easy to find an expert therapist who can help provide the benefits that come through effective therapy. They have a short questionnaire that helps match you to a therapist. And while BetterHelp has an industry-leading match rate, if you aren't happy with your match, you can switch to a different therapist at any time. Also, because BetterHelp is done entirely online, it's extremely time efficient. There's no driving to a therapist's office, looking for parking, etc. If you would like to try BetterHelp, go to betterhelp.com/Huberman to get 10% off your first month. Again, that's betterhelp.com/Huberman. I'd like to drill into motivated behavior and the dopamine system. And thank you for sharing what became of David, because always nice when medicine can deliver a victory story.
Absolutely, yeah.
Because as some people may recall, the L-Dopa for the treatment of Parkinson's had these transient improvements that sometimes can be dismaying for people, right? People get better and then they get worse again. And I'm sure there's additional progress being made there. We still need to do an episode all about Parkinson's, but we'll reserve that for another time. Mm-hmm. In thinking about motivation and the fact that there's really one system for most types of motivation, this is kind of what the David story suggests, right? That these basal ganglia nuclei, nucleus accumbens, are underlying all sorts of motivations: to listen to music, to shower, to find a romantic partner, to work, to take care of oneself, as opposed to distributed networks for motivation.
Yep.
That's interesting in its own right, I think. But many people are probably familiar with feeling really motivated to do certain things, but not others. Even if there isn't a pain point associated with doing, I don't know, maybe somebody likes arithmetic, but they don't like literature, or vice versa. Putting aside individual variation based on family history, psychology, traumatic experiences, is it true that certain people, by virtue of the way that their dopamine system is kind of tuned up, like how willing these neurons are to fire or not fire in different circumstances, are just motivated people? I mean, you see this sometimes, like, you know, I've had two different bulldogs. The first one is like, let's go. And it's like, and you have to really coax them along. The other one, let's go. Okay. And just go. Some people are like this. Hey, like, let's go. They pop up, they go. Other people, more reluctant. But I think most of us are somewhere in between. So clinically and outside of the clinic, do you think that some people's dopaminergic neurons are just more willing to fire in response to everyday activities, novel activities, and the super exciting stuff? And I have a very specific reason for asking this, but I'll keep it quiet for now, because I really want to understand, is there a continuum of motivation? And if so, can it exist both between individuals and within individuals?
Mm-hmm. So taking your first question, it turns out that this circuitry we were talking about, it's called the mesolimbic circuitry that links the basal ganglia to the frontal lobes, is almost like a final common pathway for motivation signals to engage with the action systems of the brain. So it could be hunger, it could be thirst, it could be sex. These are primary motivation signals that many animals have. But as you said, there are other motivating signals that we may also want to engage with. We may have other goals, whether it's arithmetic or to learn a new language or to go out into the park, whatever it is. Now, how those different types of motivation signals are weighted or valued within our brains to engage or not engage this circuitry to lead to action is actually a very, very interesting area. So one thing that we've learned is even apathy might be in different domains. The research in this area started with behavioral apathy, what we can measure. Is someone inert or are they active doing something? Then other kinds of work suggested there might also be social apathy. You know, we might know colleagues who seem to be very, very motivated to work, but they don't want to engage with other people or do things like go to a party or something like that. There may also be emotional apathy. So there are people who seem to have very blunted responses to things that you and I might either find, you know, something that we want to congratulate people for or feel sad about if they had an issue. These people seem to not have that kind of range of motivational responses. And some people argued that there's also cognitive apathy. So whereas someone might be apathetic to do something physical, they might not necessarily be apathetic for doing something cognitive, being curious about the world, reading the newspaper, finding out what's going on in the world. And there may be dissociations. So someone could be socially apathetic, but cognitively very highly motivated. So how does that happen? How do these different domains vary if there's one final common system? And of course, this is where we have to think about the fact that brain circuits are complicated, and the kinds of signals that are being developed for behavior, cognition, social interaction, or emotion are being formulated in different parts of the brain, even though they might funnel through this basal ganglia system to engage the action systems in the frontal lobe. And even more granular, if we want to get to that, whether you want to learn a new language or you want to do arithmetic or go to the park or whatever it is, how do you weight these different motivation signals? So one way we've thought about this is, let's imagine today, it's a beautiful day out there. What are the things you could do? And I'm sure, Andrew, you could give me 20 things you could do, but you can't do them all at once. So somehow you have to prioritize what's the thing that you value most. And the way we conceive of this is a sort of a neuroeconomic decision-making, where you look at those 20 things and you go, okay, how rewarding do I think each of these things are? And then you also think, well, how effortful is that going to be? And it could be physical effort, it could be cognitive effort, social effort, emotional effort, whatever it is. And out of that kind of system where you do a calculation, you will find the thing for you that you will value most given the level of effort required. And that's what emerges as your motivated behavior at that time.
Do you think people do that computation consciously?
I don't think they have to do it. We could do it consciously, right?
Because I don't wake up, I look at my schedule and I go, I have to do this, this, and this. I actually schedule my workouts. I schedule time with others and things, but it's sort of the constellation of things in my life. I'm not doing a very conscious weighting of this versus that. Although occasionally when there's a conflict in scheduling, I have to select. This is more valuable to me than that. But it's not something that I generally sit back and think, and I probably should, we probably all should, sit back and think, okay, what is the best use of my time, effort, reward, payoff? Right. But we sort of just go about life.
Yeah, and I think what you're really getting me towards discussing is the fact that each behavior has a kind of activation hill that we have to cross to think, yeah, I could start this. So for some people, let's say learning a new language is a mountain. That's a huge kind of effort to put in. Whereas for other people, it's barely a mount. I don't think of that as a big burden, a big activation hill that I've got to cross before I get there. So there's the activation barrier before I even think of starting. And these things are not necessarily consciously being considered. It's just you have these biases because you've got experiences. The fact, hey, I wasn't that good at learning Spanish. Do I really want to spend a lot of energy in learning French? Those biases add up and affect the way you do that calculation we were talking about, reward versus effort. And essentially, that's a very important way, I think, that we make a decision. Much of that could be subconscious.
I'll tell two brief anecdotes, if I may, to set the texture for the next question. Years ago, I was at a PhD thesis at Stanford. A student, I'll just name her because she did a wonderful job in her thesis. Her name was Lauren Case. She was not my student. I attended because she was working on neural regeneration, and she had screened an enormous number of molecules for their ability to inhibit or promote neural regeneration. Super important problem, as you and I both know, that still hasn't been solved. Yeah. And it was really striking how many molecules she had evaluated. And I will never forget her advisor's introduction. He said, one of the best things about Lauren is that she has very low activation energy, meaning there's the opportunity to do an experiment. She'd get up and do the experiment and say, that wasn't an interesting molecule, move to the next one. And it occurred to me then that having low activation energy, provided the thing that you do doesn't get you injured or killed, is really a spectacular thing in life, because you just get a lot more life out of days lived. So you kind of wonder about the Lauren Cases of the world. Are these the people where somebody says, hey, we need to do this thing, like take out the recycle and it's a ton with the roommates, something back when, and it's like, okay, I'll do that later. There's so much energy lost in the deliberation, in the feeling like the effort reward trade-off. You don't want to waste your time doing things, but you also don't want to waste your time thinking about whether or not you're wasting your time.
So let me take you up on that, because after seeing David, we thought about exactly this problem, and we got a bunch of Oxford students. And believe it or not, at Oxford, just like Stanford, I'm sure, there's a whole range of motivation amongst the students. There are people who are highly motivated, the Laurens, and then there are people who are actually surprisingly apathetic. They might be very smart people, but they have high activation energy levels. They need to cross that barrier to do something. And we put them into the MRI scanner, and we looked at their brain activity when they were given these choices. Is this option with this much reward worth this much physical effort? You just say yes or no. Would you do it or not? We could then look across this neuroeconomic space by parametrically changing the level of reward that we're offering and parametrically changing the level of effort. And it turned out, just as we'd found in patients, the apathetic students were all willing to work for high rewards, but they weren't willing to work for low rewards. Interesting. Now, in the brain, what we find is that the ventral parts of the basal ganglia, ventral striatum, nucleus accumbens, is active, as well as the parts, medial frontal areas, frontal lobe areas, in these healthy students when they're simply making the decision, is this option worth the reward for this much effort? So they're not doing anything, they're just thinking about it. We thought, great, this is really fantastic, because now we have convergence from the stroke patient that we saw with the basal ganglia lesions who lost motivation. And now we can see that healthy individuals, when they're having to make this decision, show activation in the same area that was lost in David, as well as the frontal lobes. But the paradox here was that we found greater activity in those regions in the students who were apathetic compared to the students who are motivated. And we were not expecting that. We thought if you lack motivation, your brain activity when you're being asked to do this would just be lower. So the way we have resolved this problem is to think, actually, this is showing us something very important. It's showing us that apathetic people use more brain energy when they're making this decision. They have a bigger activation energy barrier to overcome, because when they're making that decision, the brain is consuming more energy. It's consuming more glucose when it's doing that. Now, of course, in the scanner, in this sort of experimental situation, everyone's willing to do the task. They're making those decisions. But imagine these people at home. If you're confronted with, oh my goodness, I'm going to have to work hard just to decide whether I should do this option or not, maybe I just won't do it. And that's, I think, a really important insight into what you might do to energize motivation in people who might be apathetic, because it's showing us that that activation barrier that I was talking about, in a way, exists in the brain. Physiologically, you can show that these people are working harder to make the same decision compared to motivated people.
Fascinating experiment, by the way. So elegant in its simplicity, but the paradoxical piece of more activity in these dopaminergic circuits in the apathetic folks tells me, and correct me if I'm wrong, that there's a cost to thinking about the effort required, plus the cost of the actual effort required. That compounds and puts some people out of the game.
Exactly. So, the Lauren, the student you were talking about, has low activation energy. She obviously doesn't need to burn a lot of brain fuel in terms of thinking, I can do this, I'm going to do it. And, she reminds me of something that happened to me when I was a PhD student. I was in Oxford, and we would sit around having tea, thinking about great studies we could do. Nothing really happened. And then I came to be a postdoc at MIT and was surrounded by these highly motivated people. And I can remember we'd have the same kind of discussion. And then one of them would go, yeah, well, let's do that tonight. And I'd go, tonight? And that was the level of difference. It just blew my mind that there were people who could just go, right, let's do it. And I think that's been a real lesson for me, that you can achieve things if you think in this way.
Well, the other anecdote, I'll keep this brief, is a slightly humorous one, but it's designed to illustrate a point, which is I try not to spend too much time on social media unless I'm actively learning on there, because I do find things that are really interesting and educate me, sometimes just for entertainment. But there's a post I came across, and it's a little parody skit where a woman walks into the room and her husband or boyfriend is playing a video game, and she says, "Hey, do you mind hanging up those pictures that are in the hall? They've been there for a few days." He's like, "Yeah." And she walks out. She's like, shakes her head, and she has an idea. She walks back in and she says, "Hey, do you mind showing me how to hang those pictures in the hallway? I'd love to learn how." And he's like, boom. And it he launches into, so she's tapped into a component of his motivational circuitry where the opportunity to teach clearly gets him around this activation energy thing. All of a sudden the activation energy required to do the same thing just drops to zero.
And it's a very good example because, one thing you got to think about is how can you change that barrier for people? Either you make the effort less. Let's say you got a task to do, you could break it down into subcomponents so the activation level doesn't seem quite so formidable. Or you could change the incentive. And this is what happened in your example, right? The incentives change because now the guy is thinking, now the reward here is to show her how I do this. That's the thing I will get the pleasure from, the reward from, right? So I think that's the other insight we got is how do you change people's motivation in a practical way? Well, you have to think if this is really happening in the brain, that you're making decisions about whether this reward is worth the effort, you can either increase the reward or change it in some way in terms of something that's meaningful for the person, or you change the effort required to accomplish maybe part of the task, or perhaps start, just initiate the task. And often starting can be a huge motivational pull.
This gets to some sticky territory around the actual versus the perceived utility of lots of things that are on the internet, including in the health and, dare I say, wellness space, which is the following. There's this idea that if you do, for instance, a hard run or a hard workout, that you are teaching yourself how to do hard things that can translate to doing hard things in other domains. Mm-hmm. So as psychologists, neuroscientists, clinicians, we talk about the domain specificity, but that's just nerdy speak for does one thing translate to another circumstance? Are you teaching yourself an algorithm of, I did a hard thing this morning, I did the cold shower I don't like, I did the workout I may or may not have wanted to do, but so now I'm more empowered? Or, and I've thought about this quite a bit, or do we have a finite amount of energy? And the most rational approach is to think, okay, what's actually going to provide me the most benefit today? Can we really get momentum and understanding of our underlying motivational circuitries? Or is it the case that we're deluding ourselves? I'm not attempting to undercut a lot of content I've done previously, but I've had plenty of hard workouts and then gotten to the other thing I needed to do and went I don't want to do this. I'm tired from that workout this morning. But we are also familiar with the fact that if something really intriguing or exciting to us is presented to us, suddenly it's like we're a different human being. It's a complete state change. So I'm curious, I'm not asking you to editorialize about the health and wellness space, but more globally, can we teach ourselves to lower our activation energy in a way that can serve us well across the board?
I think we can, because it turns out, obviously, some of these things that people use psychologically to improve their motivation can be framed in exactly the way I put it to you, that what we're doing here is trying to either increase the reward or change the nature of the incentive. If it's something novel and salient that you think, this is really interesting, it's rewarding for me, or we reduce the effort. So just using this simple principle might be enough for someone to think about how to do it. Planning out your day or week in advance, for some people, makes life better, because every time they're having to make a decision on the fly, if they're just doing it without planning it out, means that it's costing, right? Every decision has a cost in terms, as we've seen, the brain having to invest fuel to make that decision. So if you're having to do that every time you make a decision, that can seem very burdensome. Whereas if you did it once in a big way, where you planned it out for the day or the week, maybe the costs in terms of the activation energy required for the brain is much lower for you if you do that. So it's a simple thing to do. Dividing up a task. Let's say you're given a project by your manager. It's going to take you 3 months to accomplish it. It seems absolutely formidable because you have no idea of where to start. What if you could break it down into smaller tasks, which bring down that mountain, the activation energy required to get that small thing done? Let's say, first of all, let's research one area of this and get a handle on that. And if we get that done, this is a sort of if-then kind of construct. If we get that done, we can then move on to a second piece of work. It would also help if your manager said, well done for getting that bit done, right? That's also a motivation pull to think, yeah, actually, I don't need to get the whole piece done to get the reward of somebody identified that as a positive thing to have done.
I would love to see an experiment done where the perception of one's effort to do something can be separated from the actual effort and really get to the meat of whether overthinking or even thinking at all about the effort takes us away from having more quote unquote motivation or even better performance. And I haven't had time to think this through, but as you were describing David and his transformation and this experiment on the undergraduates of valuing different outcomes, I wonder if you could put somebody on a stationary bike and put them in a virtual environment and measure the effort required to climb a hill. And you could adjust the difficulty, but you change the perception of how steep that hill is, right? Yeah. If we could translate that to the real world, like to learn something, to learn how to tango, for instance. I have Argentine relatives. It'd be nice to learn how to tango. That's a pretty cool skill, right? Yeah. There's a lot required. You got to go to the class, you got to drive there, find the teacher. If you're the one who's supposed to lead, then it's like especially embarrassing if you can't do it. So
it sounds like you've already started.
Yeah, I've started this process, but that's very different than the actual work involved in doing it, which in most cases turns out to be much lower than the perceived effort. Yeah. So is there a way to tease these things apart?
I think not in exactly the way you suggested about the treadmill and changing the perception of the gradient, let's say, that's coming. But wouldn't that be interesting? Because what we then get is subjective value of effort versus the real effort, the physiological effort, whatever it is, oxygen consumption, the glucose required, the lactic acid that's building up, all of those parameters, and seeing how that diverges. But I bet you we would find that there's a huge variation in subjective valuation.
And it could go either way.
It could, yeah.
We have a good friend, Ken Rideout, who's like a very famous within the marathoning community, like endurance athlete. And he does this mind game on his opponents when he runs. And he wins races in the Gobi Desert at like age 50 plus. He'll run up next to his competitors, this an actual event, and he'll take his earbuds out and he'll say, I don't know what it is. I never get tired. And then he wins. Yeah. And these are guys that he couldn't catch up to barely until then, and he dominates them. So there's a psychological thing happening in both of them, right? Yeah, sure. And I think he does it as much for himself as he does for them. And many competitive athletes have talked about when they see a great competitor starting to fail, how it gives them this sense that they have like a booster pack. Yep. And it's not the nicest example because I'm not big on motivating through competition per se, but it says something about our perceived effort of our own, whether or not we're overcoming the challenge. Yeah. And if we see someone else falling into a psychological trap like that, presumably it allows us to access the inverse of that psychological trap. It's like we get a boost.
Yeah, and I think what you've said is within the individual, you can change your subjective evaluation of the same effort. You're running on the Gobi Desert, right? It's the same effort you've been putting in for miles and miles. And suddenly you have subjectively valued this thing as less effort, and you're going to now, get the booster.
Wild, right?
Well,
it shouldn't work in terms of the laws of physics and chemistry and biology. The hill is the hill. Yeah. And of course, it speaks to the brain's critical role. It suggests that there's a cost all along that you weren't acknowledging. Right. Like you're removing some additional effort as opposed to like getting more energy from from the sky.
Yeah, you're not going to get that. So it is also the way you framed it for yourself, right? The activation energy required to do this, to get that little bit more from this. So I think, this simple principle actually takes us quite a long way.
You had a book that was tremendously successful. We'll put a link to it in the show note captions. And it was tremendously successful because it's an awesome book. Tons of learning there, super interesting. First book of its kind in a long while to really educate people on the brain and its workings. There have been others, but yours really did spectacularly well for its content. But you also won a big award for this, right? Do you ever think about that in terms of how hitting the pinnacle of something impacts our perception of the next effort and the next potential outcome? I mean, we think of this as quote unquote reward prediction error, but This has broad implications for whether constant scrolling on social media is actually adjusting dopamine circuits in a way that makes rewards in the real world less enticing, or whether success in one domain truly leads to confidence and success and lower activation energy in another domain, or whether or not it puts a certain pressure on us because, the rewards might not feel as great. I'm not trying to undercut any of your own relationship to this book, but what is the relationship between prior rewards or failures, memory, and motivation?
So we've talked about this calculation about reward and effort. We've gone into that in some detail. Once the behavior is initiated, it's not just initiation, it's also persevering to make sure we get to the end. And then at the end, if we get to the outcome of what we wanted to achieve, we can have a hedonic, pleasureful experience. That's what we wanted. Or we could have an aversive response. We put all this effort in, and actually it's turned out it was a terrible decision. And we've all made those, right?
Oh, yeah. Not me. No, I'm just kidding. Oh, of course.
Right. And the outcome, whether it's a great pleasureful hedonic response or whether it turned out to be absolutely awful and very aversive, obviously is graded. But that graded outcome is important for learning, what neuroscientists call reinforcement learning. And that learning comes back to affect the way we make that decision I was talking about. Which of the 20 things I could do today do I prioritize? Because if it turned out that I prioritized one, which turned out to be absolutely awful, next time it's coming up in my menu of things I could do, I am going to devalue that. So my subjective evaluation of that particular choice would be much lower. The learning mechanism is really important for choices in the future. You were talking about how previous experiences affect your motivation to do things. Well, my motivation to do that terrible thing is really going to be low next time it comes up. So I might pick something completely new, perhaps something which gives me something novel and salient that I haven't experienced before. It might turn out to be a bad thing, but I don't know. I'm going to give it a go. So I think learning is a really important mechanism in motivation. And of course, guess what? The evidence suggests that dopamine is not only important in terms of this decision-making about whether this is worth the effort or not, it's also very important in the human brain and in animal brains for learning from previous actions.
I'd like to take a quick break and acknowledge our sponsor, AG1. I'm excited to share that AG1 has just launched their newest formulation, AG1 Pro. AG1 Pro takes the clinically backed AG1 formula, which is a blend of vitamins, minerals, probiotics, and adaptogens, and adds 3 important new ingredients: creatine monohydrate, calcium HMB, and zinc carnosine. Each serving has 5 grams of creatine monohydrate to support muscle strength and performance, as well as brain health, calcium HMB to support muscle recovery and reduce muscle breakdown, and zinc carnosine to support and improve the lining of your gut. All 3 of these ingredients have compelling science to support them, and therefore I love seeing them added to the existing AG1 formula. As most of you know, I've been taking AG1 every day for nearly 14 years now. I started taking it long before I even knew what a podcast was. It's a great product, and it's now made even better with the new AG1 Pro formula. If you would like to try AG1 Pro, you can go to drinkag1.com/Huberman to get a special offer. AG1 is giving away a free bottle of omega-3 coenzyme Q10 with your first subscription. Again, go to drinkag1.com/Huberman to get a free bottle of omega-3 coenzyme Q10 with your first AG1 subscription. Today's episode is also brought to us by 8 Sleep. 8 Sleep makes smart mattress covers with cooling, heating, and sleep tracking capacity. One of the best ways to ensure you get a great night's sleep is to make sure that the temperature of your sleeping environment is correct. And that's because in order to fall asleep and stay deeply asleep, your body temperature actually has to drop by about 1 to 3 degrees. And in order to wake up feeling refreshed and energized, your body temperature actually has to increase by about 1 to 3 degrees. 8 Sleep automatically regulates the temperature of your bed throughout the night according to your unique needs. I've been sleeping on an 8 Sleep mattress cover for nearly 5 years now, and it has completely transformed and improved the quality of my sleep. The latest 8 Sleep model is the Pod 5. This is what I'm now sleeping on, and I absolutely love it. It has so many incredible features. For instance, the Pod 5 has a feature called Autopilot, which is an AI engine that learns your sleep patterns and then adjusts the temperature of your sleeping environment across different sleep stages. It'll even elevate your head if you're snoring, and it makes other shifts to optimize your sleep. If you'd like to try 8 Sleep, go to 8sleep.com/Huberman to get up to $350 off the new Pod 5. 8 Sleep ships to many countries worldwide, including Mexico and the UAE. Again, that's 8sleep.com/Huberman to save up to $350. Seems to me that the most advantageous approach would be to have a lot of generalizability about the process of overcoming activation energy and just getting into action toward a goal. Like if you do the hard workout that morning, or maybe you write a certain passage, let's take it out of exercise. Exercise is always, it's kind of a cliche example by now. You know, you're trying to learn violin or you're trying to learn a language, and it's hard, but you do a little bit of that before going to work, that it does set you up to be able to engage in effortful things throughout the day. Some things you like to do, some things you don't want to do. Okay, let's assume that one could achieve that. But in terms of failures, you want a ton of domain specificity, because if the person says, you know what, I'm going to go after this athletic goal or cognitive goal or scholastic goal, and they fail, if they attach the effort process and not the specific goal to their memory in some broad way, then it could be, I try things and I fail. Things being like everything. And that's how you described David. So I'm struck by the potential for an asymmetry in the way that this reward motivation circuitry works. On the one hand, it's very generic. On the other hand, we have a lot of ability to say, well, I'm put in a ton of work, and I'm talking about myself now, to try and learn a musical instrument as a kid. Total failure. Dogs howled, parents cringed, everyone cringed. I was happy to put it away. But I put effort towards other things and it's worked out fabulously. It's good to know that it wasn't just effort, right? But if you don't obey punishment and failure, you're also setting yourself up for a very hard life. No one wants to be the person with low activation energy who's kind of an idiot because they're always trying things and they never work out. That's, I think, what keeps a lot of people in the chair, so to speak, wondering if they should put effort towards this or that. And that's why they, dare I say, watch too many videos about motivation, right? You want to watch the right ones, but you know, you get the point.
Yeah. So this is generic in the sense that this pathway we've been talking about is if you like, a final common pathway where all of these signals converge. So in David, it took out this final common pathway. The strokes took out the final common pathway, and therefore we saw no motivation signal really was prompting him in any way of his own accord volitionally to do something. Now, the other point you make about the fact that you don't want this to be something that generalizes to all kinds of decision making. Otherwise, you'd think you're a failure. If every time you did something and it didn't work, you'd say, oh, I generalized to everything. So it doesn't seem to be like that. And we can understand that. If this is the final common pathway, the signals for decisions about playing violin, learning a new language, whatever it is, are being computed elsewhere in the brain to engage this system. This is just the final common pathway to get you that vigorous energy over the activation energy barrier to initiate the action. And then, of course, you're not going to be any good at the violin or salsa dancing or tango if you don't persevere. You have to persevere. And that's the other really important part of motivation. You know, we know a lot of people who start things. And then we also know the non-completers, the people who are always so energetic, but actually don't finish, right? So it's almost as important to be able to finish and complete as initiate actions.
Perhaps it should be required learning to do some things that you're very passionate about, but intentionally do things that you maybe even loathe just a little bit, even if provided they're not damaging to self or others or something. Because there's a real value in just what I call chop wood, carry water, where you just, and I have this mode sometimes where I just really don't want to do something. And I say like, all right, it's chop wood, carry water. I'm doing it just to do it. And you finish and you feel pretty good about the effort. And the thing you're kind of like, all right, got it done. I'm just glad to have it done. But to be a functional human being, generally, you need both. And I'm asking this on behalf of the many, many questions I get about motivation, or how do you find your passion? And I always say, well, you find your passion by getting good at effort in things that you're not passionate about, so that when you eventually find your passion, you can just get there much faster. You can't just sit around waiting to be passionate. No. I mean, that's sort of what David was doing, and it wasn't pulling him forward.
Exactly. No, that's right. And, obviously, there are different ways of getting your passion. But as you say, if you're just waiting for it to happen, it may not happen. The other thing that is important about what we were just speaking about is if you do, for some reason, generalize maladaptively to thinking, this didn't work, and I tried this didn't work, and I tried this, and I'm really bad at this, that can lead not only to loss of motivation, but what we might call clinical depression. Because one of the things that happens in depression is you think you're not good at anything, even though, that might be an unreliable, objective measure of your performance. Everything you do seems bad. It had a terrible outcome. And one of the areas that we're really getting into is trying to work out the difference between depression and apathy. And it turns out it's quite complicated, but there are some people who have pure apathy, no depression, like David, and there are other people who can be depressed, they can be sad, they can be hopeless about the future, but they don't necessarily lose motivation. They can have pure depression. And to make life really complicated, there are people who would fulfill the criteria for both apathy and depression. They fit in the overlap between those two syndromes. And trying to understand the biology of what separates depression from loss of motivation, as we see in apathy, is one of the important areas of research at the moment.
None of us want to be the person who just doesn't motivate to do anything. None of us want to be the person who motivates to do everything. And none of us want to be the person who invests lots and lots of time and energy in lots of things, and underneath it all doesn't really want the things they're going after. This is sort of the tapestry of the internet, self-help, motivation. And there's so much, I really have to say this, I've wanted to say this for a long time, and it's the appropriate time, I think. There's so much BS about, oh, is something pulling you forward, or are you pushing yourself to it? You should do things out of love. No, you should do things to serve others. Both wonderful in principle and practice. But there's this idea, and I think it's a false idea, that there's some specific thing, working on behalf of others, knowing what the purpose of what you're doing, that is somehow going to unlock this circuitry. What I'm realizing today is the circuitry is the same. The learning about what engages that circuitry is based on our historical understanding and probably the messages that we hear in our family, et cetera. This is a worthwhile pursuit. It's hard. Keep going. Trust me, it's going to work out in the end, even if it doesn't work out the way you think.
Exactly.
Those are very valuable messages to hear. But my question is this: for any of us, we've also seen the person who is very, very excited to try everything. Every idea is something that they take action on. And they seem resilient to the fact that it never really goes anywhere. It's almost like their self-concept is divorced from the outcomes. Other people have it in the opposite direction, where, like you said, they're trying things, they're getting a reasonable amount of success, certainly against the backdrop of averages. But maybe they have one big failure or a couple, and then suddenly their whole self-perception is altered. Where does self-perception come into all of this? Like one's beliefs about themselves and their ability to do hard things, both for reward and just for the sake of getting good at hard work, seems like an immensely valuable feature of the human psyche. And I don't think we have a name for that. But like the self-concept piece, in my mind, is really important.
I don't think we have a mechanistic explanation for the differences you've just suggested. Psychologically, we could think there are many reasons for that. Some people don't have high ambitions. They're happy to sit at the 50% level, maybe 51%, 52% in terms of where they sit in the population. And other people are not happy with that. That's not what they were brought up in this world to do. They want to be at the top 2%, if possible at the 1%. I don't think we have at the moment a good idea of the neuroscience that distinguishes between those two types of individuals.
Of ambition.
Of ambition, yeah.
Yeah, I don't know why I'm obsessing about this at the moment. I feel like a lot of the pain of the world is about people trying to understand what they should strive for. A friend long ago, she said to me something, she goes, "Flow, don't fight." And I was like, "What do you mean?" She's like, "Everything with you is like this like intense pursuit." And I said, "But I'm in love with the things I'm doing." And she said, "Well, it's just a lot." I thought, and then I realized, like, oh yeah, she really flows through life. She's accomplished, but it's just kind of in flow. Like there isn't this push energy. And in Eastern medicine and philosophy, they talk about, like, it gets interesting right at the level of neuroanatomy. They talk about sort of like whether or not you're pushing yourself from the back of your body versus being pulled from the front. I mean, it's mystical and vague to somebody like me trained in Western science, but I think they're onto something. Like whether or not you're expending extra energy kind of forcing yourself to do things.
Yeah.
In your undergraduate students, your patients, I'm assuming you see the full range.
I do. Yeah.
If you were to editorialize a little bit, what do you think is the key to both satisfaction from work, realistic satisfaction from outcomes, and kind of peace, like a good life?
Well, it's interesting, isn't it? Because there is some research on this. The Harvard study of aging looked at these people, these men who I think were in their late teens, and followed them up to their 60s and 70s. And my recollection of that data is really interesting, that there are some people who lived a kind of average life, and they had an average family, they had average income, they had an average house. And then there are other people who really looked like they were going to soar. And something happened to those people along the way. They didn't soar, they fell. And then finally, there was another group who actually did soar and were right up here. But when they looked at the happiness levels of these people, it was the average person who actually would self-report the highest levels of happiness. So ambition doesn't necessarily equate with happiness, which I think many people would agree with that. But on the other hand, it seems to be such an important thing for humans, right? For so many humans, it's not sufficient just to be at the 50%. We really want to propel ourselves, whether we're pushed or pulled, whatever it is, we want to get there. So it would be a great area of research, wouldn't it, to find out how ambition is encoded in the brain and how does it work, because there's also the question of realistic ambition. So if someone had told me when I was younger, don't be stupid, be realistic, you're never going to get to Oxford as an undergraduate, and you're never going to have a career where you're going to be doing clinical neurology as a clinically qualified person, doing neuroscience research, editing a journal, writing a book. That's not going to happen. If I had thought in those ways, it probably wouldn't have happened. I just didn't think that we should have these boundaries to what you can do.
Yeah, the early messaging is key.
I think it is, yeah.
Yeah, I'm the son of a scientist, and I was born and raised in Silicon Valley, and I realize only now that it completely shaped my brain in terms of, like, you want to do something, you go try it, right. and there's a good chance you can succeed. And I mean, even friends that went the way of athletics, if they didn't succeed there, they started companies that succeeded. And some crashed and burned, mind you, in all these domains. In academia too, we see it, right? Ambition doesn't protect against disease or poor judgment in a lot of times either. But it is fascinating. And maybe our species needs a distribution of kind of motivational circuitries in the way you describe. Certainly developing new technologies that transform medicine.
Yeah.
Someone needs to do that. Yeah. They can't be happy with just the scalpel and the current surgical mask and the current questionnaire that you ask patients in psychiatry. I mean, we need tool builders, and that takes a vision of something that doesn't exist, or kind of sense that there's something else.
Absolutely.
And so, God bless the people that do that, but also it's nice to have members of society that are just happy living their lives.
Of course.
Because otherwise, what else is all that technology for, right?
Yeah. No, I'm not making any judgments here. I'm just saying it's a really intriguing thing if you could get any kind of handle on what makes this happen, this range of ambition.
I didn't think we were going to discuss psychedelics, and we don't have to if you don't want to, but these days there's growing interest in what are essentially, and let's talk about classic psychedelics. Let's forget, MDMA is not a psychedelic, folks. It's an empathogen. Ketamine is not a psychedelic. It's a dissociative anesthetic. So people lump these things together, and we'll move ibogaine and LSD, and those are different in the realm of psychedelics. But psilocybin is one that's increasingly being used in clinical trials, and it's not a cure-all, but many people who are in these clinical trials come through talking about a kind of a more connected sense of self to the world. And, it seems to take the edge off of the hyper-ambitious, miserable person. That's my observation anyway. And it also seems to take some people with major depression to a place of like, oh, I actually could change. I could get a different outcome, which is simply plasticity. Yeah. So what is your thought about our ability to radically change our self-perception in terms of our ability to do things in the world, accomplish things in the world? Because that's really what getting over depression is about. It's about imagining a different outcome for oneself.
Yeah, it's a very important question. And I'm not an expert on psychedelics, but I think there is some emerging research on the effect of psychedelics on what is called anhedonia, lack of pleasure that you could get from something. So, we talked about changing effort, but it could be that one variable that happens in people with low mood is that they devalue the reward. Everything seems bland. It doesn't seem pleasurable anymore. So psychedelics seem to have an effect on the self. That principle is really interesting because the kind of patients that I study, the kind of patients that I describe in the book, are people in whom there was a change in the self. There was a change in the way they portrayed themselves to the world, their social identity, but also in their personal identity. And this is a really big area. What makes the self? But the key thing here is that the self can change. The self is not set in stone. So we talked about psychedelics, but even simple things like if you have too much thyroxine, thyroid hormone, floating around in your body, and you're in hyperthyroid state, people might be surprised to hear that that can cause not only irritability, but cognitive impacts on your processing. It can also be the same, sometimes if you lack thyroxine, if you're hypothyroid, your cognitive functions may go so low that sometimes people wonder if you're developing dementia. It can be that bad. Now, most people wouldn't think thyroxine, why would that affect the self? It's a hormone that affects metabolism, for example. But of course, thyroxine also affects neurons. And I'm just using this as an example to show that something that seems as simple as having too much or too less of a particular hormone that we all need can alter the self, the way that the self is. In people with brain disorders, from stroke, from Alzheimer's disease, from Parkinson's disease, from traumatic brain injury, the self can change remarkably. And what I try to illustrate in the book is that you can have one domain of cognitive function affected. It could be memory, it could be perception, it could be attention, it could be your understanding of concepts, it could be your representation of your body, or the way you control your behavior. Someone may become very impulsive. Each of those domains, in and of themselves, contribute to our perception of the self. Marvin Minsky, one of the pioneers of AI, called this the society of mind. The self emerges from the interplay and the activity of this society of mind. If we take one of the modules out of that society, memory, attention, language, whatever it is, the self is changed. It's not that you've deleted the self. The self has changed and it's observable. Someone's personal identity can change, their social identity can change. So I think the key point here is the self is not immutable. It's something that can change. People might think, my personality is this way, it can never change. Well, your personality is the product of your society of mind, the cognitive processes that are going on all the time, of which we are consciously aware of only a fraction. Under the hood, 95% of the stuff is going on without us consciously being aware of these processes.
It seems, and I'm not trying to play psychologist here, that fulfilling roles in our daily lives is an important part of our self-concept. I'm a student, I'm a teacher, I'm a husband, I'm a wife, I'm a whatever it happens to be, feeds back heavily on our notions of self.
Yeah.
Are we fulfilling this role well or less well? But there's another piece, and I know this exists more in Eastern philosophy, and I'm not versed in that, where we wake up each day and we know who we are. We don't forget who we are. We're carrying our prior life experience to that day. And I love the idea that we can change ourselves at the level of like optimism or anything. To me, that's like the apex of neuroplasticity. But of course, we want to hold on to something consistent. We don't want to wake up and not know where we are or who we are. That's super scary too.
Yeah.
So is it the case that when we take on a new role, that we are fundamentally changing? And it also seems that unless we're very young, most people don't add new roles over time. They might become a parent or a grandparent, have some friends, but you sort of have a limited number of roles in life. And so it seems like doing new things could actually change the self. And that seems exciting. And I think it's not a depressing thought to me that many people probably would like to change themselves somewhat or a lot. They want to feel like a different person, but not so different that they lose touch with the prior person, so they can look at is this catching?
Yeah, I understand where you're coming from. So on the one hand, of course, our ideas of who we are, ourselves, rely on our embodied self. We occupy a body. My body, the one I occupy, is different from yours. And so we have different physical identities in that respect. But we also have different perspectives, experiences. And those experiences give us our first person experiences. If I put my hand in the fire, I'm the one who's going to feel the pain. If I pick up this cup, I have agency of what I do. Those are my first person experiences. And the physical identity in terms of both the body that I occupy and the first person experiences that I have stretch back over time. And therefore I have more confidence that this is me. I've occupied this body, it's grown up, it's also aging, and I've had these experiences that make me me. I've made these choices, I've made these decisions, I have these memories. That's what contributes to my personal identity. And the other bit you mentioned really relates to social identity, my roles. When someone asks you, who are you? Tell me a little bit about yourself. It's inevitable that we'd say, well, I grew up in San Francisco in the Bay Area. I did this. I went as an undergraduate to here. I had these experiences. If you're religious, you might say, this is my faith. If you follow a particular sporting team, you might say, I'm a big fan of this particular team. If you were influenced by some very important people in your field, you might say, I am part of that school of thinking in this way. That defines your social identity. And that's a really important part of who you are. So there's the personal identity, the body, the first person experiences, and there's a social identity. And again, social identity over time is very, very important. To change from these things which we have grown up with, these identities, is possible. As we've said, it's possible through something hormonal like changes in thyroxine. It's possible through brain disorders. But these principles suggest that it's possible through what we do. And interestingly, I think there is an evidence base for this. So as we grow older, for example, as you're coming to retirement, your network of friends, your social connections often shrinks. People may have moved away. You're going to no longer have the colleagues that you interacted with because you're going to retire. Your family is now old. Your children have moved away. The network is shrinking. But it turns out that the data show across many studies that people who keep relationships, increase or maintain the number of social relationships they have a far less risk of developing dementia than those who don't, if we correct for all other confounding factors. People who have a sense of curiosity, who are open-minded, want to engage in something new, perhaps a new hobby, a new pursuit, whatever it is, they also have a far lower risk of developing dementia. And you mentioned this term sense of purpose. So, that's used or misused in various ways in different places. But if we take sense of purpose as thinking, I get up in the morning with a sense of, I need to do this, I have a purpose in life. Those people who say that are also more resilient to cognitive decline over time.
Which is a remarkable thing.
It's incredible, yeah.
And it makes me wonder if the key to evolving the self is about verbs, not labels, which sounds like a very California New Agey, like let's be about verbs, not labels. But I mean it because if you're a scientist, like people will say like, I'm a scientist. Okay, so you get a degree in science. Awesome. As an undergraduate, somebody does that means they learned a lot of science. But if you're a doctor, a physician, you're a physician and a scientist and many other things too, it's really about the things that you did and do in those roles that really shape your brain. Just having a PhD, I can promise you, doesn't do anything for you, and no one really cares after a short while. But the things you learn, the failures, your strivings, your successes, like those really shape your self-concept. It goes back to what we were talking about before about they shape our thinking about what we could do or potentially not do if we were to strive, which raises a very specific question. What does David now think about apathetic David? And what does David now think about David before he became apathetic? His memory of self is as interesting to me as the transformation. Although the transformation is clinically like remarkable and awesome, and I just want to tip my hat to it again. I mean, you saved a life, basically. It's so cool. And physicians do this. This is my admiration for physicians. But what does he think? Is he like, oh yeah, I was in a state, I need more dopamine. I take this drug, I have more dopamine, and now I'm good? And how has that evolved over time?
No, I think after he improved, he certainly looked back on the situation he was in and could not believe that he couldn't create that effort.
So disbelief.
Yeah.
Like a disconnect. Like, how could
I not have done that?
Yeah.
Because all he had to do was put the cables together to listen to music. Right? It's such a simple thing. He didn't have to do a huge amount.
But this is like somebody who has a skill telling somebody else, like, hey, you just like dunked the basketball. And you're like, yeah, but like,
but if it's you telling yourself,
right,
how can I be like that? Because obviously he has memories of what he used to be like before those strokes hit him, that he was this highly productive, very socially engaged person. So I guess you can see it afterwards, but at the time, you can't necessarily you don't necessarily have the insight. It's interesting. This week I was reading that Carly Simon was speaking about the fact she's developed Parkinson's disease. But she mentioned that one of the biggest problems is her apathy. She can't believe that she's become apathetic. Now, she obviously has insight into the problem that she's developed apathy, but nevertheless can't necessarily change that because, if circuits that affect motivation are not firing as they should be, no matter what you think, you're not necessarily going to be able to change things.
Yeah, it's like if anyone has ever had transcranial magnetic stimulation, it's like they can inhibit your ability to move a finger. And it's like you can will that finger to move with everything you've got, and it doesn't move. And then they take the coil off your head and you can tap your finger. It's a remarkable thing to feel that.
Yeah.
It's painful in a psychological way, very painful. We've all heard of mania. I'm not an expert in mania, but it seems that when people are manic, they have tons of energy, tons of motivation to do everything. Everything is a good idea. And it's mostly about them. Same if you see people on methamphetamines. It's not a very empathic state. It's not about like, what can I do for society with all this extra energy? It's a very me state. You see this cocaine, amphetamines, manic states. Every idea is a great one, and there's billions of ideas.
Yep.
So much so that people are doing trivial things thinking it's interesting or even damaging themselves or others. Are all of those hyper-dopaminergic states? Is it just this motivational circuitry, just gas pedal to the floor? And what does it tell us about motivational states? Because I do think the extremes are interesting.
So I don't know much about mania, but it turns out when I was having to present a lecture on motivational disorders, I thought I would dip in to the neuroscience of addiction. I'm not an addiction expert. And to my surprise, almost every drug of addiction, whether we go from nicotine to alcohol to heroin to cocaine to amphetamine, almost every drug of addiction hijacks that dopamine system we were talking about, this circuitry that goes from the basal ganglia to the frontal lobes. And I don't think that's a coincidence that we find when that circuitry is not working, as in David, that you can get profound loss of motivation, apathy. When that circuitry is on overdrive, because it's been hijacked by these drugs, you get states of hypermotivation. So, of course, this is going to be overly simplistic to think dopamine levels are the only factor that affect our motivation. But it certainly turns out to be a very important factor in the sort of graduating the level of motivation we have to seek particular outcomes. And of course, in the drug addiction literature, that's really become, what do you find incentively salient to act in order to try and get that outcome? But it's the same circuitry. And isn't that an amazing thing that neuroscience has stumbled on? People who study apathy like me would not necessarily study the addiction literature, but when you do, you find that there's absolute convergence between this circuitry, on the one hand being hypoactive and leading to apathy, on the other hand being hyperactive and leading to addictive states.
There's a lot that's been said about, are we constantly getting dopamine hits with online behavior? And there's, platforms are incentivized to keep us scrolling. Yeah. This is certainly true. It seems almost compulsive more than it feels rewarding. I mean, it's an interesting thing to observe oneself engaging in a behavior where the reward is gone. The subjective sense of the reward is gone, but we perseverate.
There are two things here. One is, yes, I agree with you that this sort of behavior, doom scrolling, etc., occurs. But I think the evidence that there are dopamine hits when you're doing this isn't really very strong.
I agree. And I'm grateful that you said that because people say, I'm doing this for dopamine. I'm doing this for dopamine. Certain platforms and certain content does take us into drama and high arousal. I don't know if there's dopamine associated with it. We could explore that perhaps. It's an area I'm very interested in. But a lot of it is sort of, if I may, mindless numbing out type behavior. It doesn't feel good. It doesn't feel bad.
Right.
People do often report that when they put the thing away, they're like, oh my God, I wasted some more time. But they're not really so down in the trough that they don't do it again. So there must be something somewhere in between. I agree. I don't think of it as like dopamine hits.
Right.
It's something else.
It can be something else. But the second point that you're making here is you may not actually like it, what you're doing. You may even be aware that you don't like it. And of course, in drug addiction, that's also sometimes a paradox that addicts seek this thing they want, but they don't necessarily like it. They don't necessarily get pleasure from it if they consume it. And of course, there's this dissociation in the neuroscience literature between wanting, the motivation to go and try and find that rewarding outcome, versus liking, the hedonic pleasure from getting it. And the evidence suggests that wanting, pursuit of a goal, is mediated or modulated at least by dopamine, whereas actually the liking, the pleasure you might get from an outcome is not. That seems to be related to opioid neurotransmitters in the brain. I think there's quite a lot of nice work by Kent Berridge and his colleagues on this in rodent models, but the principles still apply. There can be a dissociation between wanting to do something and actually liking it.
You're the first person to say that, online scrolling probably doesn't lead to a ton of dopamine release. It seems the experiment should be done. It's not hard to get people to scroll while in a scanner, look at nucleus accumbens, and adjust the content.
So there was an old experiment, and it was done with a PET scanner many years ago in the Hammersmith Hospital in London, when the original scanning experiments were being done. And they used a dopamine receptor ligand, something that will light up when this dopamine receptor drug attaches to dopamine receptors. And in an indirect way, you can work out how much binding of dopamine receptors is occurring endogenously with this technique. And they found that when someone was playing a video game, there was evidence that there was certainly more dopamine release in the ventral striatum, in the basal ganglia. But the parsing out, the sort of deconstructing whether that dopamine release is due to the motivation you're getting when you're playing that game versus the liking that you're getting, the pleasure you're getting, is not so straightforward, especially with PET, which doesn't have the sort of temporal resolution of doing this. So in some ways it sounds straightforward to do the experiment, but actually the subjective experience of liking and pleasure you're getting has to be temporarily dissociated from the motivation to act. And that's not so straightforward.
I'd like to take a quick break and acknowledge our sponsor, Function. Function provides over 160 advanced lab tests to give you a clear snapshot of your bodily health. This snapshot gives you insights into your heart health, your hormone health, autoimmune function, nutrient levels, and much more. They've also recently added access to advanced MRI and CT scans. Function not only provides testing of over 160 biomarkers key to your physical and mental health, it also analyzes these results and provides recommendations for improving your health from top doctors. For example, in a recent test with Function, I learned that some of my blood lipids were slightly out of range. As a result, I decided to start supplementing with nattokinase, which can naturally help reduce LDL cholesterol. And it did. In a follow-up test, I could confirm that this strategy worked. My blood lipids are now back exactly where I want them. Comprehensive lab testing of the sort that Function offers is just so important for health. I mean, how else are you going to know what's going on under the hood? And while I've been doing blood work for years, it used to be time-consuming, complicated, and expensive. In fact, I used to spend thousands of dollars per year trying to get this kind of data, and the data, frankly, were not all that good. But now with Function, it's extremely easy and affordable. A Function membership is only $1 a day, $365 a year. And if you think about the information it provides and the health challenges it helps you avoid and the proactive things that it can do for you to enhance your health, I truly look at it as a savings. To learn more, visit functionhealth.com/Huberman and use the code Huberman for a $50 credit towards your membership. Again, that's functionhealth.com/Huberman. I think of dopamine, of course, being involved in movement, which is why when it's depleted, people get Parkinson's or Parkinsonian-like symptoms. But also it seems that dopamine in an indirect or a direct way is involved in thought movement. Like it's involved in moving thoughts and ideas forward, which is sort of a piece of motivation. It's not the whole thing, and so in these hyperdopaminergic states, like people take amphetamines or they're manic, it's like everything is about the future. It's from now forward. I don't know if people reflect on the past at all in those states, but having seen, I've never tried methamphetamine. Fortunately, I don't have mania, but it seems like people are all about what could happen next. That's where they get themselves into trouble. It's kind of a fire hose of that stuff. Social media is an interesting one because you're constantly updating the stimulus. You're giving likes, you might be receiving likes, you can make comments. And so if you think about it, it's like the perfect video game that goes in a infinite loop. You just keep going and going and going, and you're never going anywhere. But all the proper bells and whistles are getting tapped on. At least when I go to Vegas, which I do from time to time, I like gambling a little bit. Like you could walk out with some or a lot more money, or you could lose some or a lot of money. I generally break even or win a little bit, like most people, because I'm tempered in it. But at least there's a potential outcome you can take elsewhere, right? So I think about this all the time. Like, what video game are you playing on social media? Not as a creator, but as a consumer. What game are you playing?
I mean, what video game are we playing in reality, in this environment?
That's the big one. Well, you're from Oxford, I'm from California, so you asked the big questions.
No, but just coming back to some of the points you made, dopamine depletion, of course, can lead to Parkinson's disease. But interestingly, a lot of researchers are thinking, is it really just action or is it motivation to action? So, the classical thing they describe is if a Parkinson's patient is in a house and they've just realized it's burning, they will be able to run out of that house.
Is that right?
Yeah. So that's what they will say, is that the motivation signal has suddenly ramped up to a level where it engages the action system. So it's a different way of framing, why is there a reduction of action? Why is there bradykinesia, a slowing of movement in people with Parkinson's disease? That's really interesting. It doesn't just have to be about motor control. It could be the motivation to act, just as we said with David, right? Because the Parkinson's pathology affects the basal ganglia. Basal ganglia is important for action, but it also has these motivation signals that link those motivations, like there's a burning house here, I've got to run out, to action, to the outcome. And the second piece you mentioned, I think, brings up the other question. Dopamine in the human brain isn't all about motivation to action. There's dopamine in other parts of the brain. We know from some really classical work by Patricia Goldman-Rakich, for example, that dopamine is important for working memory, short-term memory. It's important for holding memories in mind. And it's probably very important for executive function, the kinds of things that we might think of as either initiating action or stopping it, inhibiting it. Stopping our impulsive thoughts from getting out. We might think someone is dressed inappropriately, but you and I wouldn't say that to them. But someone who might have a change in their dopamine system affecting, let's say, the frontal lobe, can somehow lose that control and become disinhibited. So initiation of action, stopping action, possibly switching from one goal to another, and also those higher order things, planning ahead, being able to think about planning ahead. Dopamine might also be important for those aspects of executive control. So I wouldn't want your audience to think all that dopamine does is this motivation to action. There's a lot of evidence it does other stuff.
The Parkinson's person in the burning home is a remarkable result. Remarkable result.
Yeah.
Completely changes the conceptual framework around Parkinson's and what it is at a circuit level.
We've also done some more, I guess, constrained experimental studies, research studies in Parkinson's disease, where my colleague Sanjay Manohar and I were looking at eye movements. And eye movements are very ballistic. They're pre-programmed, they have a particular velocity. And what we've managed to show is if you increase the incentive, the reward you get if you make a rapid eye movement, you can find that the velocity of eye movements in Parkinson's disease can increase just as it can increase in you and me. But if you add dopamine to a patient with Parkinson's disease, that velocity increases even further. You've increased the vigor of a simple thing like an eye movement. So that goes along with this idea that it's not just inaction. You need incentives for action, and dopamine is important for those incentives.
In some sense, the person with mild Parkinson's, while we wouldn't wish this on anybody, is hyper-rational. Like, they're not going to initiate action unless there's really a potential payoff. I mean, many people have an excess of energy, so they can afford to move about and do all sorts of things and pick things up and put them down, and a lot of wasted energy out there. I'm not saying that people should give themselves Parkinson's by any stretch, but there does seem to be a kind of built-in feature / flaw of this dopaminergic system that it's so subject to learning. So prior experience can really bias us towards or away from things. That's good and bad, right? But also, the person with Parkinson's, just the mere fact that they need an elevated motivation to hit some threshold for action, I think it reveals a lot about people without Parkinson's. Like, we're wasting a lot of energy all day long.
Right. You might say it'd be efficient just to do nothing. Maybe David was very efficient. He didn't do anything.
His roommates definitely took care of a lot. It sounds like it's not functional for an adult to be like that after a while, but society sort of operates on this.
Yeah.
There's largely been made some room for people who are just not going to contribute and other people who over contribute, and then it's a distribution.
Sure.
And sort of what allows us to function. Yeah. At risk of going into really high level territory here, you said something. You said, what game are we playing here after all? It's an important one, I think, to ask. We don't want to go down that rabbit hole too often or too deeply because we can get lost. We have our roles to carry out in life after all. Yeah. But I think about this a lot. I do think the first third to half of one's life, assuming people live somewhere between 70 and 100 years of age, is about learning all these contingencies, developing social skills, what works, what doesn't work, hopefully avoiding traumas. But if you have some, eventually overcoming those, seeing that not everything has to end that way in that domain. And, and then you hit the middle of your life and you do a few more rounds of learning and extending oneself and building oneself and family and culture. But then there does seem to be something that happens to all humans is they start reflecting a little or a lot. Like, what game are we playing here? Were we just leveraged by all these evolutionarily constrained circuits and drives? Or is there something that we're supposed to focus on or aspire to? And then I think most people just shelve it. It's just way too much to think about. It's really heavy to think that maybe there is really no purpose in this. And then it's also fun and can really lift you up to think oh, this is cool. Like this game we call life is actually a really amazing gift. Yeah. Which is sort of where I live these days. I'm so grateful my parents made me, that alone. I have no gripes about anything else anymore because they made me I'm here. So many people didn't make it here. It's a great place to start, one's day. And then you have to go do stuff. So how do you conceptualize what we're going after? And for each of us, I think it is important to step back and ask these high level questions, especially after age about 35, 40, because the early part, you really are just trying to acquire the skills to navigate life.
Yeah, I think your background makes a huge difference. And as you were speaking, I was thinking, of course, this also speaks to culture, right? The culture in which you grew up also defines some of the goals, the aspirations, the ambitions you have. It could be the larger culture growing up in the United States versus growing up in the culture of your family as well. Those are obviously important aspects. So when you are growing up, I think a lot of it is dominated by the environment, that you call them contingencies, the culture in which you're growing up. But in a way, of course, as we're growing up, we are also contributing to that culture. If we have kids, we are also transmitting this information. And perhaps one of the most important things that people do between generations is transmit the culture, the local culture of the home, the domestic home, the wider culture in terms of the values shared by the tribe you happen to be a member of. All of those things shape what we do. And perhaps a generation ago, even a generation or two ago, people didn't have the luxury of reflecting back on what on earth are we doing this for? They were surviving. They were just surviving. And of course, there are many people in the world today who are also surviving. They're going, what are you on about? I just have to survive. This is not a game of anything else. We've got to a point as humans, though, where we have the luxury, some of us, that we can have time to even consider what this is all about. And one of those things, I think, is where our culture is going. That's really important. It's a very big question in the US at the moment in terms of what is the culture, what are the values we consider to be part of the tribe. How big is the tribe, actually? How many tribes are there? That's so important, I think, in influencing my answer to that question, is thinking, what game are we playing? Well, we're playing a game that's been played for centuries and generations, and that has led to human culture as we know it, highly successful in so many ways, but also capable of dysfunctional activity, as we know.
As a physician, I'm sure there are many reasons you go to work each day, but just you personally, if you're willing, where does your mind go when you reflect on your career, past, present, and future? Do you think about making a specific type or size of contribution? Like, what's deeply satisfying for you?
I've got to the point where if I have to make decisions or choices about things to do, I am going to make what I would call my deathbed decision here. I want to think that when I am passing away on my deathbed, I can look back on this decision and think, that was a valuable thing to do for me. I take pride in it. I did something useful. It could be for me, it could be for my family, it could be for somebody else. But I can look back on that and think that was worth it. So if someone gives me an option of doing something that I would say, no, that really would not be something I would be proud of or value in any way, esteem, I just say no. So the juice for me is do only the things, if you can, if you have that option, do only the things that you think will be valuable in time to come. I think I've got to that point where I can think like that. Now, obviously, there are some things we just cannot avoid. What did you call it? Wood, what was your...
chop wood, carry water.
Chop wood, carry water.
Yeah, that's a friend of mine who came from a blue-collar background.
Yeah.
Now he's an academic and a clinician. And he just said, there's some things just like when you grow up in a farmish community, he wasn't like farm per se, but, it's like rural communities, there's certain times a year where you just chop wood, carry water.
Yeah.
It's no fun. Like, you don't necessarily want to do it, but the pleasure at the end of the day is in having chopped a lot of wood and carried a lot of water.
Yeah, and sometimes, as you said, you got to do that to make the other things happen. So I understand that. I'm just giving you the extreme view. So for me, the juice is try and focus such that you do the stuff you really think is valuable. That's really important to me. I understand that may not be an option for many people.
Well, I think almost everybody, not everyone, but almost everybody has the option to read book A or book B, listen to podcast A or B, or episode A or B. And I don't think we put quite as much thought into the decision-making around those. These days, I try and do more of it. And I appreciate your answer, because I think for people who hear conversations with folks like you who are very accomplished, they assume that they're just sort of on a locomotive of achievement. Work, achieve, and you have all this. Right, exactly. But I know, based on the short time we've had the opportunity to interact and the way you answer your questions, that you think carefully about what to work on next, because it's a huge investment to work on a David versus you could work on anything. You're a neurologist. You could quit neurology probably and just write. You could do any number of different things. So as you have more skills and more agency, the choice-making process becomes increasingly important, not less.
Yep.
I'd like to talk a bit about your work on the way we sometimes can get dissociated from our environment, but not necessarily dissociative disorders. But if we could do a little experiment with the audience, I think everyone is familiar with the idea of closing their eyes and being inside of themselves, then opening their eyes and still feeling yourself, but also sensing the outside world. And then moving through the world in a way where they're kind of going back and forth quickly. You're sort of out there, but in here, out there. Of course, we're always in here. It's all an abstract construction in our brain.
Yep.
But you've studied patients where they're not seeing big swaths of the outside world. Maybe you could explain what that's called and what it is and how it changes their perception of experience on the inside. Because this is something that I hope I'll never truly understand, although maybe you have an experiment where I can shut down some stuff and do it. But this is a really important aspect of being a human that we've never discussed on this podcast and hardly anyone talks about. We can go in here, we can be out there, but usually we're somewhere in between. How does all this stuff work?
So the way many people would think about this is either internal attention or external attention. I mean, attention is just a term we use. And most of the audience will be very familiar with the idea of attention to things in the outside world. Why do we have a system for attention? And the way that many neuroscientists would put this is that the brain has limited capacity, right? It doesn't have capacity to process all the information in the outside world. It's coming at us in our eyes, it's coming at us in our ears, it's coming at us in our touch receptors, in our skin. So if we were to upload all that information, which is coming at a millisecond basis, it would be storing terabytes of information every minute or so. We don't have that capacity, nor should we, because we don't want to have neural space devoted to stuff that isn't important. Do you remember Google Glasses? They were supposed to record everything that you saw through the day. They weren't successful when they came out because most people realized that actually most of the things that are happening during the day are boring. They're not very interesting. They shouldn't be things we pay attention to. So the first point is the brain has limited capacity, so some process has to be there to select the stuff that is important for you. And that process we call attention. And how does that work, right? One way that many people think that works for the external deployment of attention is that items are competing for the selection of processing. That sounds a bit of a nebulous thing, but imagine you're walking down the street and suddenly you see a bit of a building is falling off and coming towards you. That grabs your attention, and neuroscientists call that bottom-up attention, right? It's a sensory stimulus that's really important. It's grabbed your attention, you got to move. But you can also have goal-directed, top-down attention. You go to a busy railway station, you're going to meet a friend, and she said, I'm going to be wearing a red dress. So you can filter out everything else apart from all the people who are wearing something red. And that gets you to a faster state of finding the person you're going to meet. So we've got bottom-up attention, we've got top-down, goal-directed attention. But where do we normally deploy this? I mean, so if there's something very important bottom-up, like a bit of a building falling towards you, that will grab your attention because the system is designed, our systems are designed to devote all the resources that we have to that very important threat. Now, in terms of goal-directed attention, that might also include internal thoughts. So if I'm in a lecture and I'm listening to somebody, I may fade in and out of attending externally, and then I might be captured by internal thoughts. I might be thinking, yeah, I should have really made some plans for this evening because I haven't really done that. Now, what can I do this evening, right? Should I make a booking for a restaurant or something like that? I should have done that earlier. I'm now thinking my attention is captured by these internal thoughts. So one way that we have tried to understand this stuff is that items are competing for our attention. Either external items or internal thoughts are competing for where we are focusing our resources. So attention is really just a way of explaining the fact that we're devoting our brain resources to this particular location in space or this thought. So closing your eyes, thinking internally, is really just an extreme form of putting all your resources into a particular thought. But that happens, as I said, even with your eyes open. You can be distracted by this thought in your head, even though your eyes are open and there are things going out. Because in this competition for selection, at that moment, that thought has captured your neural processing. And that's happening because the brain has limited capacity. Things are competing for selection because of that limited capacity. So you can only focus your processing on a small number of items at a time, perhaps even just one.
I think if you polled most people, they would say that they experience too much inner, what's been called chatter. We had Ethan Cross on the podcast. He's a psychologist at University of Michigan, and he wrote a book about chatter. And people would love to turn off their thoughts because most of what people report as their inner chatter is not pleasant. It's not necessarily unpleasant. It's not like you're a terrible person, what are you doing with yourself? Or it's a nuisance. I do think that some of the more effective people I've known in life have low activation energy, and they seem to think, make a decision. Once they make the decision, and there could be some contemplative time first, to be fair, they make a decision and then they are able to be fully engaged in the thing, and they're able to turn down the volume on their inner landscape. Their attention drifts out. Maybe it's in themselves only insofar as it's required to do the thing really well. I actually think this might be the flow state-ish, dare I say. Flow is a whole thing, as you know, and it gets bastardized a lot, and I don't want to do that. But there's a real cost, an energetic cost, to being in a conversation and being somewhat in one's head, except if you're me, only as required to, think about where we could go next, this kind of thing. It's just not helpful to be in one's head very often unless you're contemplating or making decisions. It's great to just turn that stuff off. I think most people would feel that way.
It must vary an awful lot, I think, because we're usually so attentive to external cues, events, right? Whether it's an appointment, something coming in an email, text, or conversation, whatever. Sometimes we also do need that space.
I think that there's a hypothesis we could wager would be that one of the things that's so enticing about high arousal media or social media is that it takes people out of their heads.
Yeah.
I'm just throwing this out there for sake of discussion.
Why not? Yeah.
Maybe it's not about what they're seeing as much as what they're not having to think about. I know a lot of people that listen to audiobooks. I have a friend, she tells me that she has to be really careful that she doesn't listen to certain types of audiobooks. She'll just use that as a way to detach from a bunch of other stuff that she just doesn't want to think about.
Right, okay.
There's a whole market for distraction and numbing and arousal and thinking in a structured way internally is not easy.
I was about to say it's hard, right?
It's hard.
So it's like this thing we were talking about. Making a decision can be hard for some people. Thinking through a problem and the potential solutions. I mean, there are some people who love it. They love the permutations. Here's the problem. How many ways could I solve it? And they'll go down one route and think, branching tree, if you go down this route, you could do A, B, or C. On the other hand, if you go down this route, you could do D, E, and F. And they love that. They love the fact that there are these permutations. Whereas for me, I'd rather narrow it down very quickly and go down, this is my favorite route, and okay, there are one or two choices to be made here. So there are different styles of thinking in your head, and maybe for some people who don't necessarily love the permutations, but end up thinking there are so many permutations, that's a big thing to do. There are too many choices here. So I'd rather just listen to the audiobook.
I have a colleague at Stanford, I'm sure you've heard of him, Carl Diceroff, psychiatrist, developer, co-developer with several others of optogenetics. And when he came on the podcast, he was actually our first guest. He said that he spends time every night after his then young kids would sleep, and now still he'll spend an hour or two just forcing himself to think in complete sentences. That's no small task.
What discipline.
right? I think most of us who like to think and think about permutations will often write and do flow charts because it's a little bit out there.
Yeah.
It's a little easier than structuring everything in here.
Well, you have to have such a great working memory system if you've got it all in here. And as we know, the more you put into that working memory system, the bigger the burden, right? Capacity limits mean that you can't hold, most of us can't hold lots and lots of permutations. We may be limited. And maybe that's what I'm expressing in myself is I like to keep it really focused and have 2 or 3 alternatives in my working memory system. Whereas if you're confronted with 15, 20 possible solutions, that's quite a hard thing for the working memory system to hold on to. And our own work in memory has suggested the quality of the information you have for the stuff you hold is diluted. The more you add into the working memory system, the quality with which you remember each bit of information is reduced. So there is also a cost from holding everything in mind.
I don't know if these studies still hold, but my last read of the studies on working memory and dopamine suggested that some people have a low, others medium, and others quote unquote high level of baseline dopamine. This is a tricky term, and our science colleagues, they're going to go ahead and, might roll their eyes a little bit at the way I'm describing it, but for sake of discussion, low, medium, or high baseline dopamine. And that if you give somebody a drug to increase the amount of dopamine in their system, and they are in the low or medium baseline group, they experience a boost in working memory, their ability to keep thoughts online for short periods of time, make use of that information. But that somebody who's already ceilinged out on dopamine doesn't afford them a benefit, maybe even degrades their ability. I find those studies fascinating, especially given the fact that so many people take stimulants.
Yeah.
Whereas a few years ago, there were some people taking Adderall, Ritalin, and 90% of adults drink caffeine worldwide. I mean, it's incredible. Now, nicotine is everywhere. Oral nicotine use in women, men, young people, and dopamine's a big part of the nicotine story. I mean, acetylcholine as well.
Yeah.
So these people who are now addicted to nicotine, I don't care what people say. You're not necessarily robbing people to get money for your pouches of nicotine, but tell them to stop. And then it's like, I'm not going to stop. They go from 1 pouch to 3 to 8 to a canister every couple of days or even day. Right. This is like happening. I'm not judging it, but chances are they're not getting a cognitive benefit, right? That they're just able to hang in there with their normal baseline.
My reading of that literature, the psychopharmacology literature in terms of cognitive enhancement, is absolutely what you said. If you start from a low baseline of performance, you might get some positive boost. It's quite small, but you might get it. But if you are actually quite a high performer, then you risk getting worse. This is called the inverse U-shaped curve for dopamine. And so I tell the students that I teach, about this sort of stuff, you're probably not going to be in that low baseline state given where you're here at this university. So just think twice about taking some stimulant that you want to get a better grade, because actually the evidence would be that you might get worse from doing it. So yeah, you have to be very careful with this. There seem to be real individual differences which depend on our intrinsic chemistry, neurochemistry.
The history of nicotine is fascinating. It's almost as if ever since humans discovered it, they find some way to get it into their system. Yeah. And once they figure out that way is really bad for them, like it can kill them from lung cancer, it takes a couple of years and they figure out another way. And then it's almost like humans love to eat and consume plant alkaloids. Like they just have to do it. They just got to feel different than their natural chemistry will allow them to.
I mean, this is our culture. Right, that's what's happened over years. I mean, as you say, if we look back, let's say in South America, cultures of how people use stimulants in various ways, that goes back thousands of years. It's not something new. So this is what our brains are used to in terms of stimulation in some way. And many of the drugs of addiction, okay, not the more modern things, but have that propensity, have been around because the culture has allowed that to happen in some way. So this is really important, I think, in terms of how our neurochemistry sort of interfaces with our cultures.
I have to imagine that given you work on attention and you work on motivation and apathy, that you get a lot of emails from parents or even kids and young people about ADHD. And many people think that they have attentional issues. Do you think there are a lot of people that don't necessarily have attentional issues? They just haven't figured out how to stop and think and make a decision about what to do next. I'm not trying to be disparaging here. I think that as each of the psychiatric disorders has become kind of more in the public discussion, like people will say OCD, they'll say, oh, on the spectrum, they'll say, you know, I have ADHD, and these are real clinical issues. But I think there's kind of a feedback where people start to notice their lack of attention. Maybe I have ADHD. Maybe I should take stimulants. You know, do you get a lot of questions about ADHD? And do you think it's a real thing for many adults, for many kids? Or do you think there's kind of a perception that we have an issue that we don't necessarily have? It's just lack of good old discipline.
I do get a lot of questions. I think it is a real issue for some people. Interestingly, you know, the number of people who remain with the diagnosis of ADHD into adulthood, if they had it as children, can reduce. Actually, the numbers reduce in terms of people who continue to have adulthood. So that's interesting, that there is some plasticity in the brain. But I also think that this is not mutually incompatible with the view that there's also overdiagnosis. And I think we need very careful ways of making diagnoses, because the conventional way is you take a history from a person about what the problem is. You may then do some degree of cognitive testing, and that degree of cognitive testing varies enormously between different specialists. And then you have to decide, where is normality? Essentially, that's what you're asking. Because you and I also get attention lapses from time to time. We also don't always perform well. We have difficulty in sustaining attention. So where do we put that marker of normality? It will always be a continuum. Right, so we're going to have to place this marker in terms of diagnosis at some point. And often that might be a point where you think it's actually having a detrimental functional effect on somebody's performance, whether it's scholastic or whether it's in social ways or whatever it is. And then it becomes more difficult because, you know, that's a much more subjective thing to decide. You've got your cognitive test, but now you have to make a decision about whether this is subjectively something that's having an impact on their everyday lives. That might be one of the places where some of the fuzziness in diagnosis comes.
Long ago, we had a guest on the podcast who's an expert in ADHD who shared that kids and adults with ADHD actually can focus quite intensely on things they really enjoy and are curious about. Reminds me of the Parkinson's patient running out of the house. Yeah. And it raises the question of whether we should train to have better levels of attention, longer duration attention, by doing boring stuff, as opposed to trying to find the thing that hooks us all the time. That too, but maybe we should do more chop wood, carry water stuff. You know,
in the Second World War, there were these studies in Britain for radar operators, because they would look at this screen. It's a very boring screen, and they were looking out for German fighter planes or bombers coming over the channel. Most of the time there isn't anything, but they could have false positives. They could push the button because they think they saw a blip, or they might drift off, which was more the worry, is that they were drifting off. Their sustained attention was drifting off, and therefore they would miss a really important event on their radar screens. And it turns out that there is something we call a vigilance decrement. Over time, if you're doing something boring and dull, healthy brains, you will find a reduction in your ability to detect these boring, very infrequent events. You can measure it. And one of the problems that's been found in ADHD is there can be a difficulty in sustaining attention over time, not necessarily because they miss things, but also the variability in response is something that's become a signature of people with ADHD. They're far more variable than people who are not given that diagnosis, if we believe the diagnosis was made correctly at that time. And I think that's telling us something really important about this, because that variability might reduce if the motivation to do this was better. So you mentioned intrinsic motivation, in the sense that if they're doing something they're really interested in, they might be more focused in order to do that. And the neuroscience, I'm not a specialist in ADHD, but the neuroscience that I have read about suggests that it's not only the parietal and frontal regions of the brain which are important in deploying attention to the external world. There may also be dysfunction in the basal ganglia in people with ADHD. That's been referred to in some ways as being involved in working memory, but it can also probably be involved in motivation. So we're bringing these themes together here, that attention might also be related to motivation because you're more likely to pay attention to something that you think is intrinsically rewarding to you.
Maybe we could drill just a little bit further into the nucleus accumbens and this basal ganglia circuitry, because I think most everyone is familiar with the fact that some goals are very short term. I'm going to make a cup of coffee. I'm going to drink the coffee. Yeah. Some are long term. I always say, if nothing else, get a PhD because you'll teach yourself that you can work on things for long periods of time, sustain a lot of effort and uncertainty, and provided you complete it, and I trust you will, you get something at the end. And so you have this ability to say, well, I can do hard things, uncertain things over 4 to 6 years. I mean, that's not alone a reason to do it. Hopefully you're interested in what you're doing. It really helps. Yeah. But do you think there are ways that this circuitry learns different time contingencies? That it must, right? I mean, if the same circuitry is involved in motivating to make a cup of coffee because it feels worth it to me to get the caffeine and the taste, that's responsible for trudging through something over several years, an endeavor or relationship of any kind, and it's the same circuitry. That suggests there's a really robust and dynamic dial on how it integrates time, right? I mean, it's a totally different game. In one case, it's like a slot machine that has a high probability of success, like making the coffee, right? It's almost every time you actually get the coffee. And in the other one, it's like, we're talking years. Yeah. So the same neurons, they're clocking over vastly different timescales. How does that work?
So I think most of the studies that have been done are over very short timescales. They're what you're talking about, the slot machine type of study. We've also done some studies recently looking at perseverance. But again, they're not over years that we normally have to think about when we're making long-term goals. I don't think it's necessarily timekeeping in the basal ganglia that's the issue here. I think these are much higher level goals and plans that you might think are being constructed in the cortex, particularly the frontal cortex. We talked about executive control and planning. Planning has not been studied in great detail, except for some relatively simple problem-solving tasks that patients are given to do, which usually can be done within a few minutes. But this extended long-term planning and perseverance, I don't think that's something that the basal ganglia do. Those networks are there from the lamprey, right, to solve getting my motivation signal to action. But this extended motivation to do something over years for a long-term goal, I think must be something which is different from what's going on just in the basal ganglia. And of course, then it also brings into this issue about what's called temporal discounting. So if I say to someone, you will get this great rewarding outcome, but you have to persevere for 1 year, or I say to them, you'll get this sort of mediocre outcome and you'll get it within a week, people will differ in which ones they'll choose.
What are the current data on that? Does it divide in some sort of like 2 marshmallow experiment kind of way? Still,
The marshmallow experiments have obviously become very controversial in terms of...
I heard they were debunked. Then someone came on the podcast who works on these and said the debunk was debunked.
Yeah, I'm not an expert on those studies. But I think the key thing I'm just trying to explain is that also people differ in their levels of how they will discount the reward that they're willing to take with time. And that varies enormously between people. So what is it that allows someone to say, I'm going to wait for the bigger reward after a year rather than take this mediocre reward in a week? I don't think we've really got the neuroscience of that.
No, it's tempting to say that to pursue long-term goals, you want to break it up into short-term goals. But I always think about these asymmetries. Like if we said, okay, you have a 5-year goal, and in order to get there, you're going to use the same reward circuitry and motivation circuitry, but you're really going to pay attention to the small wins along the way, the incremental wins. The risk is that you also pay attention to the failures along the way, right? Because in the end, it's binary. You either get the thing or you don't in most cases, certainly with a degree. But with wins and losses, they're graded, as we say, like they're not 0 or 1, they're 0 to 10, and it's very subjective. And so I feel like perseverance for me has a lot to do with making the pain a shorter experience than the win, like carrying forward our wins and our memories of being motivated. Like if we kind of allow those to seep into our self-concept a little bit more, then it's sort of like, oh yeah, you can do hard things, but it's a little bit of self-delusion, but it's a functional self-delusion, right?
Of course.
I don't know how one could get a medical degree without engaging in some amount of functional self-delusion.
Yeah.
Right.
I mean, it's tough.
Yeah. You've worked on, as I mentioned earlier, a huge number of issues. I don't expect us to go into all of them today, but I know many people are interested in Alzheimer's disease and the loss of memory due to aging. What, in your mind, are some of the more interesting findings of past, present, and maybe anything that you did in particular that changed your notions of memory and Alzheimer's?
I think one of the most interesting things that much of the audience would not be aware of is Alzheimer's disease does not necessarily equal dementia. People can have Alzheimer's disease and not get dementia. So we found this out from post-mortem studies. People have been followed as they age, they've donated their brains, and it turns out that perhaps 20 to 30% of these individuals who never had dementia have Alzheimer pathology. What do we mean by that? We mean that when we look down under the microscope, you can see the signature of Alzheimer's disease. You can see plaques, which are made up of this protein amyloid, which has been deposited in the brain. You can see tangles, which are made out of this protein tau. And you can see that also perhaps some of the neurons have suffered, they've died in these brains, and yet the person never developed dementia. So the first point I think is really important is Alzheimer's disease can increase in the brain as we age, but it doesn't necessarily have to lead to dementia, which is a really important point. So what's the difference between the people who can cope with this burden of pathology in their brain and remain cognitively relatively intact? Why do they have this cognitive resilience? And a lot of people are investing funds to try and work out what's the difference between these people. Of course, there might be biological differences and lifestyle differences. It could be, the people who can be resilient are the ones who've had a routine of physical exercise. They've made sure their blood pressure never got too high. They've made sure that, they don't have pre-diabetes or diabetes, or they check for it. Their cholesterol is under control. They're not drinking too much alcohol. They're not smoking. All of those things can be important. But it turns out that actually there are other factors that can be just as important. We talked a little bit about these. Those include that having that sense of purpose, making sure that you have a network of people, that you're socially connected as you age, and also remaining curious, open to new ideas. Those factors turn out to be almost as important as some of the physical things we do. And we're just scratching the surface of trying to understand how those factors affect the biology. How is it that having a sense of purpose makes a difference to how you cope with this burden of pathology in your brain? But in a way, that's a really interesting, optimistic thing to learn about Alzheimer's disease, that it doesn't necessarily always lead to dementia. And by the way, I should also just explain for the audience that although Alzheimer's disease is the leading cause of dementia, there are many, many causes of dementia. So again, Alzheimer's disease is not the only thing that can cause dementia. In terms of our own work, one of the things that we've really tried to do is extend the kind of work we were talking about with loss of motivation and apathy into people who develop Alzheimer's disease. And in fact, perhaps even before we're aware they've developed it. A lot of studies in the last few years have shown that if we just study healthy aging people they don't have dementia, they don't have any diagnosis of a neurological disorder, what we find is that those individuals who score highly on just self-reported questionnaires for motivation, if they score highly for apathy, they have twice the risk of developing Alzheimer's disease than people who don't. And the conclusion that is emerging is that Alzheimer's disease is not necessarily just about cognitive impairment. It can also lead to behavioral changes long before you develop any sign of cognitive impairment. And one of those behavioral changes happens to be apathy, loss of motivation. So if you can pick that up at an early stage, could you potentially do something about it? Because the evidence suggests that these pathologies in Alzheimer's disease, the amyloid and the tau that's being laid down in the brain, that can be more than 10 years, perhaps more than 15 years before somebody presents to a doctor with cognitive complaints. So we've got this huge window, maybe 10 to 15 years before someone comes along and has a diagnosis of Alzheimer's disease. So if we could detect this at the earliest stages, maybe the drug therapies that have developed and shown very small changes, the monoclonal antibodies that mop up amyloid, have shown that even in established early Alzheimer's disease, they can make a small difference to the trajectory of the illness. Maybe those monoclonal antibodies could make a difference if you could do something 15 years before someone develops Alzheimer's disease, if we could detect it in the brains. So I guess these are perhaps some of the most interesting things that I think I've been stimulated by in the last few years.
I wasn't aware that one could have plaques and tangles, so-called Alzheimer's, characteristic signs of Alzheimer's, and yet not have dementia. It sounds like certain people, by virtue of having sense of purpose, engaging in the world, and who knows, maybe even the reflection back onto who they are, sense of self being reinforced. I'm making up that portion of the story, but I like the idea, no basis for it, but no direct data for it, rather, are resilient to their own internal landscape. It's an interesting way of thinking about neurodegenerative disease because we think about exercise, crossword puzzles, social connection, Mediterranean diet, and all these things, and good cardiovascular health in general, buffering us against the pressures of the outside world. But the idea that our thoughts, our self-concept, our emotions could buffer us against our internal neural landscape, that's pretty exciting because that's something that, as you mentioned, if you could start early enough, well, it would benefit us anyway. Why wouldn't we do it?
Of course.
Right? Yeah. It's just good for us across the board.
What's the harm in doing that?
Right.
Yeah. But that is an exciting new development. But of course, that has all sorts of implications. Would you tell someone they have Alzheimer pathology in their brain when they weren't going to develop dementia? You're spoiling the party here, right?
That's a tough one. These days there's a lot of interest in whole body MRI. A friend of mine who's a neurosurgeon says that he gets people in his clinic all the time who spotted things in they paid to go get their own MRI and it saved their life. But he gets a lot of calls from people that are concerned about white spots on the brain or growths in the brain that are basically of no concern clinically. And it's a tough call. And there's a financial piece where some people can afford to do this and some people can't. And so it's become a point of contention. But this is how we used to talk about genetic data in the late 80s, early 90s. I remember the discussion like, would you want your genome? And some people say, well, if I'm going to get Huntington's, well, wait, no, maybe I wouldn't want to know. And other people say, oh, I would absolutely want to know. It's a very complicated issue.
Yeah, and you need informed choice. So you need to have enough information before you make that choice. And of course, as you said, maybe some people are financially able to do this sort of stuff and others aren't. So it has huge implications going forward. But again, there's so much excitement in brain diseases that we couldn't potentially think about treating years ago. For example, the landscape in multiple sclerosis. When I was a junior neurologist, all we had was steroids, corticosteroids, to give to people who had relapses of multiple sclerosis. Now, there are a huge range of immune therapies for multiple sclerosis, which has transformed the lives of people with that diagnosis and the disability in that condition. You can't be a general neurologist in looking after multiple sclerosis patients. You have to be a real hyper specialist because there are so many therapeutic possibilities. And for neurodegenerative diseases, it's a tough call as well, but so much has happened in a condition which was thought pretty untreatable 30 years ago, apart from giving steroids. So I think this is an area that's become really exciting.
It's a good time to become a neurologist, if anyone's thinking about it. Whereas maybe a few years back, I had a more depressing view of neurology. It sounds like things are really on the upswing in terms of tools and approaches for treatment.
Again, 30 years ago, deep brain stimulation for Parkinson's disease was just being introduced. And I used to think, what are these guys doing? They're putting these patients through this terrible surgery. There's risks of infection, hemorrhage, all these kind of things. Now I look back and I think you have to take those pioneering steps, take the risks, because there are patients with Parkinson's disease who have had their lives transformed by this sort of radical treatment where you have deep brain stimulation of the basal ganglia. I mean, that's an incredible achievement. And so if you could have that, why can't you have deep brain stimulation in other neurodegenerative diseases, provided you found the targets for that stimulation well? And why can't you have focal neuropharmacological treatment, which would mean that you wouldn't necessarily get any of the toxic side effects or unwanted side effects of drugs that you might give systemically or intravenously in some way? I think these things are coming.
I think so too. I'm excited about intersectional methods, like giving a drug that potentially could increase dopamine everywhere, but you give another compound that directs it specifically to the components of the brain that you're interested in. Yep. And so you relieve side effects. That stuff is being done in animal models, and we're not quite there. Yep. I feel like we're getting there.
That's right. And some of my colleagues in Oxford and elsewhere in the world are using focused ultrasound to open up the blood-brain barrier, the zip that covers the brain, so that it's focally opened up at the location you want to deliver the drug.
Oh, that's cool.
I mean, that's,
very cool.
Fantastic if you can achieve it.
I'm excited and encouraged by these MS results. We have a colleague here that has MS, and we haven't done an episode about it yet. We need to, but that's super encouraging. Super encouraging.
Yeah, it really is transformative in that field.
You've been very generous with your time. Before we wrap up, can I just ask you a few more questions?
Of course.
Okay. People will wonder if there's anything they can do to increase their attention or ability to stay focused in stuff that isn't super engaging for them. Is that a skill?
The studies that have been done there have really focused on things like playing video games or stuff like that. And you can improve on those sort of tasks. But what you mentioned before, this doesn't necessarily generalize to other types of activity. So it seems to be very task-specific, domain-specific in that way, hyper-domain-specific. So training your attention, I'm not sure there is such great literature which I would think I could point you to. This has been also tried in people with stroke and who lose attention, like the neglect syndrome. And again, things improve on the task, but they don't necessarily generalize to other tasks.
Can we train to not get distracted? So the inverse of that. Might seem like a crazy example, but in the world of mouse genetics, I learned a long time ago that it takes many generations to evolve a trait, but it doesn't take very many generations to devolve a trait. So you can just breed some mice, pretty soon you'll get interesting mutations that you can study, and you can find the role of particular genes, put them back in. But if you go and you try and say, we're going to breed mice for a while until we get an interesting outlier, and then we're going to study that outlier, you're going to be an old human before you even get something that might be interesting.
Right.
And that's for me was a very informative example, because in the realm of attention, maybe we can't get better, but maybe we're doing a lot of things in our daily life that are degrading our attention, and we just rescue a little bit of that, and we're like, I am actually much better at focusing than I thought.
Yeah, so I think although there might not be a great deal of evidence that you can intrinsically train your attention to do better generally, what you could do is to cut out things that are distracting for you. I mean, these are simple things that people will be very familiar with. Make sure you don't get notifications. That's a really important thing that many people don't do, right? Or keep your email open while you're doing something else. Make sure that there isn't some sort of distracting noise wherever you're doing that. So you could do things in your environment to cut down distracting stimuli that will capture your attention.
I sometimes wonder if there's both a pleasure and a pain in giving something our full attention. I now look at the world as, okay, what's effective in grabbing people's attention and distracting them? What's effective in grabbing people's attention and engaging them? Okay, well, drama, arousal, and numbing out are very effective at grabbing people's attention. But I think I and others have experienced this thing, I know I have, perhaps others, where when you try hard to really focus on something, it's a pleasure once you get through it and you get someplace, but there's a kind of a pain to it also. And so perhaps the attention economy isn't so much about grabbing people's attention, it's about distributing it over a certain array of things where they can potentially make money. I think about this a lot lately.
Yeah.
And I think, wait, what I'm getting back when I'm getting much better, getting so focused, because I have a pretty laser focus when I want to. I learn a lot of it in here. I'm not thinking about anything else. But were my mind to flit to something, I can grab it right back. Is my attention and focus getting better? Or are we just not allowing ourselves to get pulled into the array of other things? This has been a pleasure, I should say. But as you say, hard work is hard work. Focus is hard work, and hard work involves a bit of friction. Does this make sense?
Yeah, and I think it goes back to that conversation we were having about economy of what you do. You know, is it better to be inert? Is it better to allow your attention to just focus on one thing? Or is it better to allow it to be deployed widely, to be captured by different things? So there might be an economical benefit for the brain and for Andrew to just devote resources to a few things rather than to many things. So reduce the choices.
I don't normally ask these sorts of questions, but I feel compelled to ask, and feel free to say pass. What do you do for enrichment? I don't like the word fun. For enrichment, when you're not thinking about the brain or engaging with family and that sort of thing. Like what do you like to do to stimulate your mind if it's not work or family?
Yeah, I really like drawing. I like art.
Okay.
That's something I get a lot of pleasure from. I mean, I do physical things too. I'll go to the gym as well.
Sure.
But the thing I really like, I wish I had more time for, is art and painting. If I could do that, I would love it. But I know I'd have to devote a lot of resources and time to do that properly, to do it well.
What do you draw? Is it neural related? Is it biological?
I drew the figures, for example, in the book. I really enjoyed doing that. But I can draw anything else that I fancy. It could be a still life, whatever it is. But I don't take a huge amount of time, but I get a lot of pleasure from doing it.
And you have thoughts about other things while you do it, ideas and that kind of thing?
That will come, but there is just an intrinsic pleasure from disengaging from everything else and just, even if you spend half an hour on something like this, which doesn't necessarily have value to anybody else, it's just for you, it's something you're doing, and maybe improving your skill in this. So maybe that's what you might call enriching.
Well, it certainly is. As someone who likes to draw, I can relate, but no matter what people enjoy doing, I hope they heard your answer clearly. I knew there was a reason I asked, which is interesting people always have a lot of interests. This is like kind of obvious when you hear it, but it's like interesting people have a lot of interests and they pursue them even if they're not trying to, have their work in the Guggenheim or something, although you probably will, knowing you Oxford types, Thank you, Dr. Masud Husain. I appreciate you very much for the work you do. Your patients certainly appreciate you for the science you're doing in addition to the clinical work, for the fact that you write books, that you go on podcasts, and that you share information that is interesting and relevant to everybody, because this is, after all, the human experience, sometimes pathologies and overcoming them, but always the reflections on the quote unquote normal everyday human experience is what's so relevant to everybody. I've thoroughly enjoyed this conversation. Hopefully we can encourage you to come back across the pond to talk to us again in a few years, because you're moving at a rapid rate and it's going to be hard to keep up with your discoveries, but please do.
Thanks for a really stimulating conversation. Thank you.
Thank you for joining me for today's discussion with Dr. Masud Husain. To learn more about his work and to find a link to his book, please see the links in the show note caption. If you're learning from and or enjoying this podcast, please subscribe to our YouTube channel. That's a terrific zero-cost way to support us. In addition, please follow the podcast by clicking the follow button on both Spotify and Apple. And on both Spotify and Apple, you can leave us up to a 5-star review. And you can now leave us comments at both Spotify and Apple. Please also check out the sponsors mentioned at the beginning and throughout today's episode. That's the best way to support this podcast. If you have questions for me or comments about the podcast, or guests or topics that you'd like me to consider for the Huberman Lab podcast, please put those in the comments section on YouTube. I do read all the comments. For those of you that haven't heard, I have a new book coming out. It's my very first book. It's entitled Protocols, an Operating Manual for the Human Body. This is a book that I've been working on for more than 5 years, and that's based on more than 30 years of research and experience. And it covers protocols for everything from sleep to exercise to stress control, protocols related to focus and motivation. And of course, I provide the scientific substantiation for the protocols that are included. The book is now available by pre-sale at protocolsbook.com. There you can find links to various vendors. You can pick the one that you like best. Again, the book is called Protocols, an Operating Manual for the Human Body. And if you're not already following me on social media, I am Huberman Lab on all social media platforms. So that's Instagram, X, Threads, Facebook, and LinkedIn. And on all those platforms, I discuss science and science-related tools, some of which overlaps with the content of the Huberman Lab podcast, but much of which is distinct from the information on the Huberman Lab podcast. Again, it's Huberman Lab on all social media platforms. And if you haven't already subscribed to our Neural Network newsletter, the Neural Network newsletter is a zero-cost monthly newsletter that includes podcast summaries as well as what we call protocols in the form of 1 to 3 page PDFs that cover everything from how to optimize your sleep, how to optimize dopamine, deliberate cold exposure. We have a foundational fitness protocol that covers cardiovascular training and resistance training. All of that is available completely zero cost. You simply go to hubermanlab.com, go to the menu tab in the top right corner, scroll down to newsletter, and enter your email. And I should emphasize that we do not share your email with anybody. Thank you once again for joining me for today's discussion with Dr. Masud Husain. And last, but certainly not least, thank you for your interest in science.